good day to Dr. Noor Hafiza. We are from Group 11. My name is Elementary Paniselvam with a matrix number of 283095, and this group consists of the members who is Muhammad Izzuddin, Aiman Haikal and Noor Shahir Maliati. The topic of our project is forest fires. Forest fires are a major environmental issue, creating economical and ecological damage while endangering human lives. To counter such phenomenon is to know the key element, which is fast detection. Automatic tools based on local sensors such as provided by meteorological stations are used to achieve this. In this research, a sample survey was conducted to get to know about the factors of forest fires using meteorological data. It is hoped that at the end of the study, we can conclude on what factors that drive forest fires make use of the system more in the future to avoid such phenomena. The objectives of the study is to identify the coordination where the fire took place in the forest, to investigate frequency for each item that affects forest fires, and to observe that burnt area from January to December. Next will be data collection. Our type of study is descriptive research. Descriptive statistics can be defined as a method for collecting, organizing, analyzing, and summarizing data. It can be used to describe the basic features of the data in a research, which is mainly about the what than the why. They contribute simple summaries about the sample and the measures we have. Together with simple graphics analysis, they form the basis of every quantitative analysis of data. Descriptive statistics help us to clarify large amounts of data in a practical order. In this case, it refers to the factors of forest fires using meteorological data. Data could be collected in various ways. We use the secondary data since the data we received is a random collection of data samples which has been already collected and readily available in other sources. In our research, the data we used is the observation data from January till December of forest fire using meteorological data. Since secondary data have been used in this research, we are led to evaluate the data that helps to achieve objectives. Method of data analysis. As you can see, the list of measurement scale of different variable table is placed in this video. FFMC, DMC, DC will be nominal, ISI will be ratio, temperature is an interval, relative humidity, wind speed, rain and area will be ratio. Measurement scale. Next, let's move on to data analysis and result. Based on the data shown in the table and figure, that on September is the highest, which is 34.7% of forest fire with the amount of 52 frequency on that month. Next, on January, April and June recorded the lowest forest fires with 1 frequency and represent only 0.7%. Since the September month has the largest frequency, which is 52, the mode or most typical month is September. Moving on to the day. Based on the table and the figure above have shown that Wednesday recorded the lowest frequency among the other day with 6.7% and 10 total frequency only. Meanwhile, Sunday recorded as the highest frequency that has been recorded 18% of forest fires with 27 total frequency. The mode of the day of forest fires is Sunday since the total frequency of Sunday is the highest compared to the others. The bar chart above shows the fine fuel moisture code FFMC index of the forest fires data. Based on this chart, the highest FFMC is in the range of 87.5 to 92.5 with the amount of 99 frequency, which represents 66%. Next, the lowest FFMC is in the range of 69.5 to 80.5, which only have 1 frequency and represents 0.07%. The mean for the FFMC data is 90.4. Moreover, the variance and the standard deviation are calculated as 21.92 and 4.682 respectively. Following on to Duff Moisture Code DMC index. The bar chart above show the Duff Moisture Code DMC index of the forest fires data. Based on this chart, the highest DMC is in the range of 24.4 to 45.4 with the amount of 28 frequency, which represent 18.7%. Next, the lowest DMC is in the range of 2.4 to 23.4 which only have 10 frequency and represent 6.7%. The mean for the DMC data is 84.47. Moreover, the variance and the standard deviation are calculated as 1717.79 and 4.45 respectively. Next will be drought code index, which is DC. Based on this chart, the highest DC is in the range of 639.3 to 743.3 with the amount of 75 frequency, which represent 50%. Next, the lowest DC is in the range of 114.3 to 218.3 and 324.3 to 428.3, which only have one frequency and represent 0.7%. The mean for the DC data is 488.3. Moreover, the variance and the standard deviation are calculated as 70,952 and 266.368 respectively. The bar chart in above shows initial spread index ISI of the forest fires data. Based on this chart, the highest ISI is in the range of 0.7 to 8.7 with the amount of 85% frequency, which represents 56.7%. Next, the lowest ISI is in the range of 54.7 to 62.7, which only have 0 frequency and represent 0% of the data. The mean for the ISI data is 9.20. Moreover, the variance and the standard deviation are calculated as 41.85 and 6.469 respectively. Next will be temperature. The bar chart above shows the temperature. The highest temperature is in the range of 15.3 degrees Celsius to 19.3 degrees Celsius with the amount of 60 frequency, which represents 40%. Next, the lowest temperature date is in the range of 30.3 degrees Celsius to 34.3 degrees Celsius, which only have one frequency and represents 0.7%. The mean for the temperature data is 18.26 degrees Celsius. Moreover, the variance and the standard deviation are calculated as 23.9 degrees Celsius and 4.89 degrees Celsius respectively. Next one will be relative humidity. As you can see, the bar chart above shown the relative humidity of the forest fires data. Based on this chart, the highest relative humidity is in the range of 28 to 40 with the amount of 53 frequency, which represents 18.7%. Next, the lowest relative humidity is in the range of 80 to 105, which only have 2 frequency and represents 1.3%. The mean for the relative humidity data is 40.64. Moreover, the variance and the standard deviation are calculated as 300.4 and 17.332 respectively. Based on the table and figure above, the highest speed of wind is in the range of 3.9 km per hour to 5.9 km per hour with the amount of 92 frequency, which represents 61.3%. Next, the lowest speed of wind is in the range of 6.9 km per hour to 8.9 km per hour, which only have 18 frequency and represents 12.0%. The mean for the wind speed data is 4.46. Moreover, the variance and the standard deviation are calculated as 3.286 and 1.813. Therefore, this indicates that the most wind speed is between 3.9 km per hour to 5.9 km per hour. On the other hand, when it comes to rain, according to the table and figure shown above, we can see that the most of the outside rain is 0 mm per square meter, which represent 99.3%. The total frequency for 0 mm per square meter outside rain is 149. Conversely, the percentage of 0.2 mm per square meter outside rain is 0.7%, which represent the total frequency is 1. Therefore, this shows that the mode of the outside rain data is 0. In area, the highest of the burnt area of the forest is between 0 hectare to 0.17 hectare, that represents 92%, and the total frequency is 138. The lowest of the burnt area of the forest is in the range of 0.18 hectare to 0.35 hectare, which only have 0 frequency and the percentage is 0%. The mean for the burnt area of the forest data is 0.140. Moreover, the variance and the standard deviation of the burnt area of the forest are calculated as 0.041 and 0.202 respectively. Therefore, this indicates that the most of the burnt area of the forest is between 0 hectare to 0.17 hectare. Finally, the coordinations. Based on the table and figure above, the highest total frequency and percentage among all coordinates in bracket x and y is coordinate 3, 4 that represents 20 of the total frequency and the percentage is 13.3%. The coordinates 1, 3, 1, 4, 5, 5, 6, 6, 7, 3, 8, 3, 8, 5 are the lowest total frequency and the percentage among all coordinates, which is 1 and 0.7%. In thesis of this report, forest fires have an immediate effect on mortality not associated with accidental deaths, which is a significant public health problem, especially if the fire occurs near a densely populated area. Good day to Dr.